Thank you, Vice Admiral. Senator Saeed, distinguished guests, naval officers, ladies and gentlemen. Assalamu alaikum. H.O. Wallingford's involvement with Pakistan's blue economy began in 1959, supporting the development of Karachi Port. In the 1970s, we were instrumental in the development of Port Qasim. So it is my great honour and pleasure to be invited to speak today at this wonderful event. I'd just like to make a small correction or comment on the scope of my presentation. I'm not going to talk about port design. That's a very broad and complex subject, and I'm happy to discuss that over lunch, which I'll hurry up and we'll all get there sooner. I'm going to talk more about the design of navigation channels, and particularly the application to the work that we did at Port Qasim just a few years ago. So just to give a bit of context, navigation approach channels, they're critical infrastructure present at most ports. Usually they're a dredged channel. Some lucky ports around the world, very little dredging, if any, is required. So their correct design is crucial, mainly from the point of view of navigational safety, but also from the efficiency of the port. A poorly designed channel can compromise navigation, maneuvering, and the throughput to the port. It's also very important from an optimization of dredging quantities point of view. Good channel design will minimize that, and dredging is expensive business. There is industry best practice guidance when it comes to channel design, and that was a working group led by H.O. Wallingford a few years ago now, which set the baseline, the international benchmark, if you like, when it comes to how you go about designing navigation channels. A note of caution there that although the guidance exists and it's a good document, it's well put together, experience and competence is required in its application. And hopefully you'll see why as I move through. Next slide, please. So I don't think I need to give too much of an introduction to Port Qasim, but in terms of port context, it's nationally significant, if not internationally significant, as a port facility. It handles large vessels already with a wide variety of cargoes and commodities as throughput. And there is an aspiration, rightly so, within Port Qasim Authority to develop the channel, increase the capacity, reflecting the changes in the shipping industry and the port sectors in recent years. Increased containerization, the advent of very large vessels, some 400 meters long with 60-meter beam. But this is a challenge. How is the port going to accommodate this change, this increase? It means longer vessels, increased draft, increased beam, and importantly, as we'll see towards the end of this, increased inertia and mass. So the channel design process is well set out by PIMEC, and there's three key elements. The first one, which unfortunately you won't be able to pick up on the slides, is about the needs, the demand. What is the need and demand to increase or modify your channel? We then move to a stage of concept development. So this is where we feed in the ideas, the aspirations, the existing data that's available. Perhaps there's an idea of the design vessel, and we think about how the channel may look at a concept level. Then there's usually a stage of further technical study, once that the concept is set, to modify and refine that into a detailed design. So I'm going to talk about the application of the concept design and the detailed design to the work that we did at Port Qasim. So a key statement to make is that the design vessel is key. That governs the geometry of the channel, its depth, its width, and any special considerations around diameters of turning basins, etc. The design vessel that we considered for our work with Port Qasim is ultra-large container ship, ULCS, 400 meters long, 59-meter beam. So these are large vessels, some of the largest in the world. In terms of Port Qasim, we then need to think about how does that affect the channel? Does it need to be widened, straightened, deepened, and how can the design be optimized? So starting at the concept level, the table there really gives a list of parameters that affect the width of the channel. For example, what are the wave conditions going to be experienced in the channel? How strong are the currents going to be? Is there a requirement to allow vessels to pass, etc.? And once we work through this process, you can come up with a first estimate of the increase in width that the channel needs to have. Effectively, at Port Kazim, there are two channels. There's the outer channel, the Asan channel, which is exposed to stronger currents and increased wave conditions, which necessitates a slightly wider channel than you have in the interior. So how does that look? Probably the best thing you can do is pick out on the colors there. So the blue represents an extension in the length of the channel to accommodate the deeper draft. The green areas show that dredging is required, and the yellow areas show where the channel needs to be widened. There's more detail there on the slide in terms of positioning of aids to navigation, etc., but it gives you a plan at least to work with at a concept level. We repeated this analysis for the inner channel, and the width that is determined is about 250 meters, which is about 40 meters less than the outer channel. And we can see exactly the same sort of analysis there. This time the pink area represents areas where passing would be possible, particularly when we have the larger beam vessels accessing the channel. So moving on to the second stage of the work and the best practice, if you like. You've developed a concept design of the channel. Now it needs to be validated and tested. And PIMEC is very clear in its recommendation that that is through simulation, and that is also needs to consider varying operational conditions. So we're blessed at Wallingford with having a world-leading ship simulation center, where we can modify and represent in real time the interaction of the vessel physics, the waves, the currents, the winds, and from an operational or practical perspective as a mariner and a pilot, changes in visibility and the visual cues that are ever so important to safe navigation. So I just wanted to share with you one of the important findings of our study when we were going through the detailed design process. And it really emphasized the importance of doing things properly and by the best practice. If a less detailed study had been undertaken, it's very probable that this finding wouldn't have come to light. So the images I'm presenting on the screen show a track plot of a vessel, ULCS, navigating up the channel towards QICT. And on the left-hand side, you can actually see that the vessel starts to step out of the channel. The pilot and the captain are doing their best to control the vessel under the conditions, but because of the increased inertia of such a large vessel and the preceding set of bends at the port, it actually becomes quite a challenge with these potentially larger vessels that are being considered for the port. So this came out in the real-time simulation. We then went back to the design process of the channel, and it's quite clear that you can see there, I've just highlighted where the vessel stepping out of the channel. The channel needed to be widened. Now, if we'd blindly followed the guidance early on at the concept design, this wouldn't have happened, and straightened. So there are a set of bends before we get to this point in the channel that cause this issue. And you can see that the vessel now is set in a much better way, approaching the curve. So there's the summary there that I'm giving is really about the technical considerations of the study. But my kind of broader high-level view of this is it pays to do studies properly. It's the right thing to follow the guidance, follow the science. Ultimately, you don't want to have a channel that's poorly designed, compromises the operational efficiency of the port and the future-proofing of the port to accommodate larger vessels in the future, and saving money. I mean, that's what this is about, particularly through the dredging element. So I think that's it from me, and thank you very much.